systems of linear equations in two variables. Since we're talking about system, which means there are two linear equations that we have to find the solution. And later we're gonna show you the graph of each equation so that we're going to find out which is their point of intersection, which is their solution. So you have learned that when the graph is intersecting, the system is independent or consistent. And when the graph is parallel lines, the system will be inconsistent. And lastly, when the graph is overlapping or coinciding, the system is dependent. So now the system of linear equations into variables, we are going to find the solution of those equations. The solution of those equations is their point of intersection. So therefore, only the intersecting lines have solution because there is a point of intersection which is here. And also, there are infinite solutions when the graph is overlapping or when the system is dependent because there are many points here that they intersect. Actually, they do not intersect, they just overlap. Well, that's probably the same. So now I'm going to teach you how to solve systems of linear equation into variables. So now we're going to start with the basic. First example is x plus y equals 7 and x minus y equals -1. So the first thing we have to do is to eliminate one pair of variable. It can be either x and x or y and y. So since x is here, we're going to eliminate x first. So now to eliminate x or a variable, we have to choose either addition or subtraction to make the sum or difference 0 so that we can eliminate it. So we're going to do subtraction here. So this is going to be a minus sign and there. Since x minus x 0, then y and there. Since x minus x 0, then y positive y minus negative y. We're going to do keep change here. So we're going to change this the operation into addition and the sign of the other into positive. So now we're going to add y plus y is equal to 2y and 7 plus, we're going to change this, 7 plus 1 is equal to 8. So now we're going to find the value of y. So since this is 2, we're going to divide both sides by 2. So it's going to be y is equal to 8 divided by 2 is 4. So therefore, the value of y in these equations is 4. So now we're going to find x by using substitution method. We're going to substitute y to 4 and we're going to choose one equation. We're going to choose the first equation so that it's going to be easy. Okay, the first equation is x plus y is 4, so we're going to write it as 4 is equal to 7. So now I substituted the value of y here, which is 4, and now we're going to solve for this. We're going to find the value of x this time. So it's going to be x is equal to, we're going to what do you call that? We're going to transpose this variable into this side. So it's going to be x is equal to 7. We're going to change the sign minus 4. So this is it. So now we're going to do this as we're going to do subtraction. So it's going to be x is equal to 3. So we already have the value of x and y. So earlier we have found out that y is equal to 4. So therefore the point of intersection of these equations, which is x plus y, I'm just going to write it so that you can see, is equal to 7 and x minus y is equal. Their point of intersection is 3 and 4, which is 3 Cartesian plane. So later we're going to show you how to graph this equation. I'm just going to show you where it is located. So this is 3. So 3 is x is located in the x-axis because it's an ordered pair. It should be x and y like this. It should be always like that. It shouldn't be like y and x. It's wrong because we just have to follow this one because it is correct. So x is 3, so this is located, since it's positive, it's located here, and 4 is the y, which is located, oh, it's kulang. It's located here, 1, 2, 3, 4. So when we draw a line to this is their point of intersections. Later, Mr. Monte Clara is going to show you how this is going to be graphed in a Cartesian plane. So that's it. Our first equation is first system is an intersecting because it has one solution. So therefore, their point of intersection and the solution to this system is 3 and 4. Gosh, the camera is not working well. So that's it. Hey guys, so I have here another system which is x plus 2y is equal to negative 4 and 3x minus 5y is equal to negative 1. If in this case we cannot instantly eliminate a variable because it's not balanced. We cannot, if we add this, it's gonna be 4x, and if we're gonna if we're gonna subtract this, it's gonna be balanced. This entire equation, we're going to multiply it by 3, so it will become 3x plus 6y is equal to negative 12. I'm just going to repeat it because you cannot see it clearly. 3x plus 6y is equal to negative 12. So I multiplied it by by 3 so that it will be balanced when we can easily eliminate x because 3x and 3x are the same. So if we subtract them both, the sum will equate to 0. So we're gonna just copy the other equation. 3x minus 5y is equal to negative 1. So now what we're gonna do is eliminate x. So we're going to do subtraction. So 3x minus 3x 0, we're not gonna write it anymore, and we're going to do keep change here because it is subtraction of integers. So we're going to change this to addition and change this to positive, which will become positive 5y. So 6y plus 5y is equal to 11y, and change this also because it's keep change. So it will become 12, negative 12 plus 1 is negative 11. So since this the coefficient here is 11, we're going to divide both sides by 11. So which means y is equal to negative 1. So that's it, guys. We already found the value of the first variable. So now we're going to do substitution. If we're going to substitute, we can use the first equation which is not yet multiplied by 3 because it is easy. So now we're going to do substitution. If we're going to substitute, we can use the first equation which is not yet multiplied by 3 because it is easier because you're not going to transform it to lowest term or simplest form. So now we're going to do substitution. So it's gonna be x plus 2 and y is equal to negative 1 equals negative 4. So we're going to multiply this both. X minus 2 equals negative 4. So we're going to transpose this in the right side, which will become x equals negative 4. Change the sign when you transpose, plus 2. So when you add this x is equal to negative 2. So we already have the value of this system. So y is equal to negative 1 and x is equal to negative 2. So now guys, we're going to show you how the graph looks like in this system. So next, Luar.
Hello everyone. So today I'm going to show you how to graph system of linear equations in two variables. This is surprisingly easy if you know how to change standard form into slope-intercept form, which is y is equal to mx plus b. So you need to change the standard form into slope-intercept form. So let's do it. Now, you need to transpose y to the other side. So this will be y is equal to negative x plus 7. Since we transpose x, it's the sign of x changes from positive to negative. So this is the slope-intercept form of the standard form of this equation. Now let's do the other one. So this will be negative y is equal to negative x minus 1. Since y can't be negative in this formula, y can't be negative, we have to multiply it by negative 1. So the product will be y is equal to x plus 1. So now we have our two slope-intercept form equations. We can graph them. So as you can see, I already have graphed the entire equation or the entire system, if you would. So to graph, you must first look at the the slope, the intercept, the y-intercept, and the slope. So these are very important for graphing. Now, since this is 7, and since we are using the slope-intercept form, that means if you're getting y, then x is always 0. So with that in mind, the coordinates for the y-intercept is 0, 7. So we are going to start at 0, 7, like this. I already did it. Now, look at the slope. Coefficient for the slope. Since this is only x, we can get, this is only negative x, we can get negative 1 from it because it is equal to negative 1x is equal to negative x. So in every x, there's always a 1 which is invisible. So we need to get the rise overrun of this. So the rise overrun of this is negative 1 over 1. So we have to rise at least, we have to rise 1 time, negative 1 time, and we have to run 1 time. So since this is negative, we have to go down. So we have to go down. So the point here, we start at here, then go down by 1, since this is 1. Go down by 1. Then, since the run is 1, you need to, and it's positive. So if it's positive, you need to go to the right. If it's negative, you need to go to the left. While the rise, if it's positive, you need to go upward. If negative, you need to go down. So this is positive. The run is positive, so we need to go right at 1 time. There. So the coordinate, the point transferred from 0,7 to 1,6. That is the slope. Slope of this is -1, so we have to do it all over again until we get a line. Now, all of those lines that we see in the all of these points in the line are solutions to the equation. This is only one equation, so it doesn't apply to this one. So we need to do it over and over again. So we go down by 1, and we go down by 1. We go right by 1. We go down by 1. We run by 1. We go down by 1. We run by 1. We go down by 1. We run by 1. Now, that is the pattern of this line. Okay. So, from all of these points, we can draw a line to it. So, all of that points are solutions to the equation. So, in graphing the next equation, we just need to do the same thing that we did to the other one. So, since the y-intercept of this is 1, so we need to start at 0, 1, which is in the y-axis here. Then the slope is 1 over 1. Since this is x, there is an invisible 1 beside it. But you can always remove 1 and x. You can also leave x. So we have to rise 1 at one time, and we have to run by 1 time. Since this is both positive, we need to rise up. We need to run to the right. So, let's start at -1. So, we have to rise by 1, and we have to run by 1. We have to rise by 1. We have to run by 1. We have to rise by 1. We have to run by 1. And to get the other side, if it's too short, you can always add more. Just change the signs to its opposite. Like 1 over 1 can be -1 over -1. Since -1 over -1 is equal to 1 over 1. So, since both of these are negatives, okay, so now we can graph it. Since both of these are negative, we have to go down. Go down by one side, one time. Then go to the left, because we have to run once. So, okay. So, we start at 1. So, we go down by 1, which leads us to the origin. Then, run to the left by 1. We go down by 1. Then, we run by 1. We go down by 1. Then, we run by 1. So, now, we can connect all of these points to make a line. All of these points are solutions to this equation. But, we are finding the solution. We are trying to graph to find the solution for both equations. Now, when you have already graphed it, the solution now is easy to find, since the solution for the systems is the point of intersection, which is 3, 4. So, the solution for the system is 3, 4. You can try to solve it if you want, but when you already have a graph, it's alright. It's